Well, why doesn't the air just flow directly from high to low? Why is it circulating? It's going around in these circles, clockwise and counterclockwise. Why doesn't the air flow directly from areas of high pressure to areas of low pressure, like those two yellow arrows indicate? In the case of the northern one, the air is going straight from the subtropical high toward the subpolar low. And the southern one, it's going straight from the subtropical high to the equatorial low. Why doesn't the air do that? Why does it bend? What's going on with this? Remember, the Earth is rotating, and it's rotating under the movement of the air. We call this the Coriolis effect or the Coriolis force. No, it has nothing to do with your toilet. The Coriolis effect is the impact of the Earth's rotation on freely moving bodies like wind and water currents, and for that matter, planes flying through the air, missiles going through the air, or a bullet going through the air. It causes a deflection to the right in the northern hemisphere. Just before I go any further, think about this. You have a high pressure system in the northern hemisphere and it's circulating clockwise and out. If you're at that H and you move in any direction away from the H, what direction the wind's going to be going? They're going to be making a right-hand turn. This is from the Coriolis effect. Take a look at the left-hand side. You can see that if the Earth was not rotating, this is what air would do. It would go directly from high to low. But because the Earth is rotating, the air is trying to go directly from high to low, but that rotation causes this spinning effect. In the case of high pressure, the air is going to circulate clockwise and out in the northern hemisphere. So if you look at those arrows on the right-hand side, the arrows are trying to get to the low pressure, but because the Earth is spinning underneath it, it bends around and the low pressure sucks it in a counterclockwise circulation. Okay, you're up in space, and you're looking down on the northern hemisphere. That dot right in the middle of the blue circle is the North Pole, which means that darker blue that circles the circumference of what you're looking at there would be the equator. You cannot see the southern hemisphere at all. Remember, the planet is a sphere. As the Earth rotates, it rotates from west to east. But if you looked at this from a northern hemisphere perspective, the Earth rotates counterclockwise. If you're looking at it from a southern hemisphere perspective, although we're still rotating west to east, the Earth is rotating clockwise. Take a globe and spin it and take a look. That's what happens. Rotate the Earth from west to east and take a look from the northern hemisphere. It's going to be going counterclockwise. From the southern hemisphere, it's going to be going clockwise. Now, it's a merry-go-round. And the merry-go-round is rotating counterclockwise. And you are on the merry-go-round at position A1, like the steak sauce. Significant other is directly across from you on the merry-go-round at position B1. Okay? So you're at a park and the merry-go-round is rotating counterclockwise and significant other is sitting directly across from you. This would, by the way, make me very sick. And as it spins, you have something in your hand. You have a ball. You're going to toss the ball to significant other. Here's what happens. When you toss the ball, you and significant other move. The ball continues on that straight path, but you and significant other move. And in fact, the merry-go-round rotates underneath the moving ball. What that does is it creates an illusion for you when you're at position A2 and significant others straight across from you in position B2 of the ball making a right-hand turn. Now, is this a perfect analogy for the Coriolis effect? No, because there's other things involved in this. Pressure gradient, drag because of atmospheric friction and earth friction. There's other things involved, but this will do for our purposes. And if you take a look especially at position A, notice that as the Earth rotates, you can see the axis up at the top and it shows the rotation of the Earth. That what's going to happen is the path is going to make this bend off to the right. That's what the Coriolis effect is doing.